Myatt of Magic Communications. John's going to be talking today on the cloud to ground and ground to cloud application development tools. Please say hi to John.
All right. So I'll start with a preface. This is an introductory talk about these tools. If you are already an expert on Ansible or Terraform or something, you may know more about them than I do. So don't look for this to be the deep dive PhD course about Ansible and Terraforms. Look, I scared away 2 people just with the introduction. That's scary. But, you know, it is an interesting topic, and that's why we're here. Okay, how do we drive? That works. So you may have heard some of these buzzwords about infrastructure as code. And what on earth does that mean? Well, what it means, the concept is that you describe the problem you're trying to solve in code or something that looks roughly like code. And then there's some magic chain of tools or something that you hit deploy and it goes blah, 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 and magically all that stuff you described gets translated into configuration of equipment in your plant, and it all sounds great. Now, why would you want to do that? Well, there's a couple reasons why you might want to do that. First off, you can, in principle, change control that code, that blob of text, right? So you can keep versions of it. You can go into it and change one line and then redeploy. That's the idea. That's exactly what people are looking for when they talk about infrastructure as code, is the idea that literally you can describe what you're doing, describe what you're trying to configure in this big configuration file, and then deploy it. Now, if you think about all the things that happen when you hit that little deploy button, well, what is it? You might have to create or allocate resources, which, that means there has to be a list of resources. You might recover, or, if you actually if your configuration changes and you're removing a resource, you have to actually remove it properly. If your configuration involves modifying some details, like a configuration of something, you have to, do that properly and clean up. But the whole idea is that when you make an incremental change to that master configuration and you hit deploy, that it makes that incremental change and doesn't screw up everything else. So, believe it or not, this problem's not unique to the television industry. So the IT industry for years has been solving this same problem, and they developed some tool chains. And just like in television, also in the IT world, if there's any problem that's worth solving, there's going to be 4 or 5 competing, completely different ways to solve it. So in television, we see this because there's 5 ways to take UHD video around a plant. And in IT, you'll find that there's multiple tool chains that people use to solve this very similar sounding problem. So the ones I'm going to talk about today are Ansible and Terraform and Kubernetes and the general topic of CI/CD, because CI/CD is the meta topic that infrastructure as code kind of fits underneath. So the first one of these, if you just go on the web and you start searching around a little bit, the first one you'll probably find links about is Ansible. So you say, well, what is Ansible? And if you type in Google, what is Ansible, you'll get answers that don't help you that much. But the way I think about Ansible is an automation tool that can also automate, among other things, provisioning. Now, provisioning is a telecom word. And what provisioning means is if you think about, you call Verizon and you ask them to provision a circuit, that means they're going to order the equipment they have to order. They're going to allocate the things they have to allocate, like wires on a pole. They're going to go schedule a service technician, and they're going to actually configure all those things. And they use the word provisioning to mean all that. So Ansible is an automation tool. Its focus is automation, but one of the things it can automate is all those provisioning tasks. Now, that means that you would build and change and revise infrastructure by just defining it in a file and then use Ansible to execute that file. Okay, well, in the words around Ansible, we're all about this Ansible uses the concept of a playbook. So a playbook is what they call that big file that describes your whole plant. And the playbook is full of plays, which a play describes something to be done and a list of resources you're supposed to do it to. So if you're going to go, configure 10 people's laptops to have some new tool, then that list of 10 laptops is the list of resources, and the installation of the new tool is the task. And then it calls that a unit of work and shoves that out in a thing they call a module. Why they plays and playbooks and modules, they use these words like fluidly, and the documentation is a little confusing about this. But that module executes on the laptop. So your Ansible thing has to actually be able to log into the remote machine that it's going to do the work on and does that work. So if you think about that, that's all stuff you could write a giant pile of PowerShell scripts or whatever your favorite language is to do stuff and build your own version of this. But Ansible is written already, and it's built, and it's supported by Red Hat, and there's a lot of nice things about it. And so Ansible is what people use. Now, if you had to write your own versions of all these little plugins and playbooks for every piece of equipment, you'd get tired of it fast. But the beautiful thing with Ansible is that the vendor community has by and large embraced Ansible and written these things called collections. So a collection is a collection of playbooks and segments of playbooks for configuring things. So if you talk to Arista, they'll point you at a website full of Ansible collections for configuring Arista switches. If you talk to Cisco, they'll point you to a website full of collections for configuring Cisco switches. It hasn't so much caught on in the television equipment community. If you call Imagine and you say, hey, I want an Ansible collection, I'll ask you a lot of questions about what you're going to do with it first, because I really want to understand. But I believe that this will become more and more common, that there will be Ansible collections that define and describe common tasks for configuration of television industry equipment. Because these systems are super helpful, because you can use them to describe what do you want to have happen in your plant and configure it. And so I put a few helpful links in here for the collections list and where you find the documents for Ansible and so forth. So these slides and these videos all wind up on the IP Showcase website later, and those links will be in there. If I was a streamer, I'd talk about popping that link down below, but we don't go there. So then there's Terraform. Remember we talked about different tools to do the same job different ways. So Terraform is more or less a provisioning tool that also has some automation capability. So where Ansible leads with being an automation tool, Terraform is more of a provisioning tool that has some support for automation. But again, it's the same idea. You build and change and revise your infrastructure by describing it in a file. And Terraform, of course, has a completely different vocabulary. So in Terraform, we talk about providers and plugins and resources. So a resource is an object like a virtual machine or something, and a provider is, believe it or not, a chunk of code from a plugin that does a thing. So it's not like your phone service provider, but it is in a sense. So the interesting thing with Terraform is that the language of the provider and the language of how everything is described to ensure idempotency. Now there's a word that doesn't even come up in English very often, probably doesn't translate into any other language very well, except directly. Idempotency is the most important thing about any of these schemes. Because idempotency is the property that says, if I push that deploy button and stuff happens, and then I go back and I push that deploy button again and stuff happens, I wind up with the same result each time. Now, that sounds great, right? But if you think about that set of scripts, whether it's in Ansible or Terraform or whatever, and all the stuff it's doing, it's allocating addresses and allocating resources and picking one off the list and putting this over here. You got to be really careful when you create these scripts and plugins and collections that you don't allocate something twice, or that you don't allocate it again the second time somebody runs it if they already had one, or if you don't destroy one that went away if somebody else was using it. All these kinds of catchy cases. And so the underlying logic inside Terraform is really designed around this idea that ensuring idempotency. It's a big, big issue in the way they construct the language and the way they build everything inside Terraform is around this kind of abstruse but important concept. Now, just like with Ansible, there's third-party collections of these Terraform providers that are collections of providers. And I would say that, just like I said, there's a reasonable number of them, but there's nowhere near the number of them that there are for Ansible. So as a potential user of these things, that to me was pretty indicative of where's the industry going. Except it's not that clean because there's a lot of Terraform adjacent products that are sort of like Terraform but are different but similar. And so many of them, there's one called Argo, for example, Argo CD, that's used mainly for deploying to Amazon. It's kind of in that whole Amazon deployment tool chain. There's another one called Flow CD that's adjacent to Argo and similarly. So it's like this horizontal universe of Terraform adjacent and similar things that have many of the same properties, and it's a bit confusing, but that's what's down that Terraform path. And again, most of the big third parties try and have libraries for both, but I would say it's easier to find Ansible collections. Whether they all work, that's always the next challenge, but they might work for you. And don't take that as a dig. That's just the state of the open source world. Then there's Kubernetes. Now, Kubernetes is its own animal. Kubernetes is a cluster orchestration system or automation and provisioning. So it has its own language for spinning up things. Now, Kubernetes is also the mechanism you deploy into. So if you have a Kubernetes cluster, it has a whole bunch of worker nodes that can do stuff, and then a control plane that knows how to deploy things onto those worker nodes. And it's a way that's very commonly used for organizing multiprocessor, failover, fail-safe compute projects, where they approached it from the axis of being able to ensure redundancy of the application. So instead of just worrying about how do you stand up your application once, Kubernetes was built from the focal plane of how do I build a resilient infrastructure that resilient applications deploy onto and have the orchestration system run dynamically as opposed to just being push the deploy button. But the underlying logic of how do I deploy, what do I deploy, how do I model state has the same set of problems of idempotency and how do you ensure that and how do you manage that. And again, each one of these tools has a totally different vocabulary. So Kubernetes talks about objects and their state, their desired spec, and their status, their current state. And then they do whatever you have to do to drive the current state to match the expected state, which might be that there should be 3 of these running. There's not 3 of these running. I better spin up another one. Those kinds of logics are really built into the Kubernetes control layer. Now, so that's the focus really there is about, it's like I said, it's a orchestration tool for deploying things into a cluster of Kubernetes nodes and dynamically managing those and making sure they stay up and making sure they get configured the way that your scripting said. And they have tools for load balancing and a lot of other nice things. So depending on the application, Kubernetes can be a great environment. Now, it too is extensible and has both extensions to the controller and extensions to the way it handles networking and the way it handles devices. And there's lots of Kubernetes adjacent plugins and projects that make plugins that go work with it. So, lots of choices, which is unfortunate because if your goal is that you're looking for someone to tell you what to do, basically it depends a lot on what you're trying to do. There's some things like, configuring switches and networks and stuff. Ansible's actually really good at provisioning real physical tangible infrastructure. If instead what you've got is an application that's already segmented into worker nodes and you're looking for how do I deploy that into an organized cluster, boy, Kubernetes is great at that. If what you have is an application that's mostly VM images that you want to deploy into cloud or into on-prem infrastructure that's already stood up, Funny enough, Terraform's really good at that. So each one was kind of developed by people with a specific problem they were trying to solve, and then expanded into the adjacent solution spaces. Now, the words that we talked about are important. So there's two words that come up that are like science-y, computer science, awesome words, and my professor would be proud, but immutability is one of them. And this is important when you're deploying systems to have identifiers. So like we've all worked in things where we've seen GUIDs, these, big long strings of characters that you look at and you say, oh, but those GUIDs are important because they're basically immutable identifiers. If you spin up a thing and it gets this identifier, later you look and you say, I have a thing with that identifier, you know for sure it's the same thing. And that's how you can keep track of not allocating another one, not making an extra one by accident, all those kind of things. And that helps you achieve the second word, which is this idempotency, that every time you run your deployment system, every time you re-execute that, deploy now, or in the case of Kubernetes, every time it notices it has to do something, that it does it in a way that doesn't create extra stuff and doesn't create, two copies of something or delete the copy you needed. That property is really driven through all of the plugins and everything else, is how do they achieve that? And that's the thing you have to do your most testing on, in especially Ansible, is by every path of what could happen, do I wind up, in idempotent configuration. So these tools are used in a larger scale process called CI/CD. Now, for a company that makes products, especially software products, CI/CD is a very common tool. It's used by most everybody. And what it means is you do continuous integration and continuous delivery. Oh, what's that? Continuous integration means literally you take people's changes, you put it together, you build it, you test it, usually in a very automated way using automation platforms like Jenkins. We use Jenkins. There's 5 of them. And this is sort of common practice in large-scale software organizations for probably the last 10 years. But the notion of using it in television production and in configuring facilities is a very new notion. The idea that you can have, say, your template for a standard playout channel, and you make changes to it, you deploy it to a test environment, you make sure it's perfect, then you can deploy it to a production environment. That set of checkpointing and the various, change control processes and bug tracking processes that we use in software development, applying those to infrastructure management and infrastructure maintenance seems very appealing, and a lot of people are talking about doing it. But it's definitely in the ascendant phase right now. I don't know too many people that are really doing it full hog. They're just, it's a startup. So a year from now, we'll probably be talking about how it's going. But let's get back to the real brass tacks question. Why are we sitting here at the NAB show talking about this? Well, these tools, if you're a large organization, a large broadcaster, you might actually have a software development team that can use tools like this to deploy infrastructure. And if you think about the old days, right, in the analog days, everybody who worked on TV cameras had a little green screwdriver in their pocket and they knew how to use it. And I've read about those people, right? I used to have a green screwdriver, but Andy probably has two green screwdrivers still. But they weren't expected to design that big analog camera, but they absolutely knew how to tweak everything in it to make a good picture. And that was just part of owning something that complicated like an analog television plant, was knowing how to pull out your green screwdriver and use it. Now, in the file-based workflow universe that we live in now, again, there's all these complicated systems doing media asset management and moving files around and this and that. And do the engineers actually know how all those systems in their plant interact? Well, yeah. There's at least somebody in the plant that understands how all those things interact, because if the line in automation is red and says that asset's not available, like a lot of things get sideways really fast in your facility if the asset management isn't moving things around. So yeah, in every facility, there's somebody that knows how to go make that thing work again. And you can't be calling whoever to get it working. Well, in this version of the universe of television that we're moving into, where things are software based and dynamically deployed and so forth, there's a lot of interest in getting the business benefits of those models. But it creates the staffing question of, is that going to be something that television engineers in plants are responsible for? What is the layer of dividing line of who's responsible for what and what skill sets are they going to need? So, we aren't expecting television engineers to go write the code. Some will. Some will do it as a hobby. Some may go and do it as a profession. But what we do need is to understand the expectations of what is the dividing line in the future between what is the vendor responsible for delivering and what is a customer responsible for maintaining. And it's not like the old days where you can make a box and the box has a spec and the box has a cut sheet and it does what it does. These are dynamic systems that deploy and change and modify and have to be actively owned and actively maintained. And getting as an industry to that understanding of who's responsible for what products are going to have to exist, or is there a whole new product category called a deployment system that manages these things? These are the questions that we're wrestling with as an industry. On the next slide, I do not have an answer to that question, but that's where we are. And your interest is welcome. And if you're watching this online, my email address is pretty easy to find, and I look forward to a conversation about it.